Now I am going to show you a very interesting kind of test. I want to give you ideas on what you might be able to do. I am going to set up a new experiment. Click on the plus sign. Rather than design a new experiment algorithm, I am going to import one. Click in the top right corner to import. I have a test that I have run before. You will notice that it is a complicated test compared to what we have done so far, but I will explain it to you as we go through it. Let me first save the test. I am going to call it plus SP minus SP measurements. Click on Save. Normally the way the test machines work is that they measure when a sample is flat, or unstretched, or unbent, or measure when the sample is folded, or stretched, or bent, not both. I want to measure when it is flat and when it is folded in a single experiment. I will start applying devices. I will use HP1 and the HP template. This test is not possible with the DLDM or HB. I will use the Hioki meter and the Hioki front panel template. I will use the Logitech camera. Here's the way this algorithm works. Before the test machine starts, we will make a measurement. I will start with the sample flat and the plus SP stop position. Note the comments on the right side. Then I will move the motor one cycle and it will stop with the sample folded and make a measurement. While the motor is stopped, I will change the stop position to be minus SP. This is an operator step. The operator must make stop position changes using the motor's touch panel. Then I am going to repeat a sequence 5 times. You can see that I have grayed out several blocks. I will explain this later. I will move the HP 3 cycles at 30 RPM and then stop and make a measurement. When the motor is stopped, I will change the stop position to be plus SP. Then the motor will run one cycle and stop with the sample folded and make a measurement. While it is stopped, I will change the stop position to be minus SP. This will happen for 5 total iterations. Every time the motor stops flat, I change to plus SP. Every time the motor stops folded, I change to minus SP. After it has run those 5 iterations, it will leave the loop and stop flat and make a final measurement, and then the experiment will be over. The reason for these other blocks is that I can set up an alert that will stop the machine until I click on the alert. Before I click on the alert, though, I need to change the stop position on the motor. I set up the alerts to tell me if I have to change to plus SP or to minus SP. The purpose of the alert is to make sure that I do not miss changing the stop position at the right time. You cannot change stop position while the motor is running, only when it is stopped. But if I am slow or distracted and miss changing the stop position, the motor will proceed without changing the stop position, and I will have messed up the experiment. Another way you can do this is to make the motor pause for some number of seconds to give you more time. But that still assumes the operator will be there ready to change the stop position. The safest way to do this is to use the alert. Suppose you are running 1,000 cycles between measurements. The operator will have to be there for the few seconds that the motor is stopped. And of course you can do the experiment without the alert or pause. That's what I will do right now, but the operator must be especially diligent. Before beginning the test, I want to make sure that the sample is in the flat position, and reset the motor count to be 0, and make sure the stop position is set to plus SP, and make sure that the touch panel is already on the settings page where you set the stop position. I have to walk over to the motor to do that. Now I am going to start the test by clicking on Execute. I will call it the plus SP minus SP test. Then click on Execute and immediately go over to the motor. The motor will run one cycle and stop folded for a measurement, and I must change to minus SP. The motor runs 3 cycles and stops for a measurement, and I must change to plus SP. The motor runs one cycle and stops for a measurement, and I must change to minus SP. Then the motor will run 3 cycles and stop to measure, and I must change to plus SP. When it runs one cycle and stops to measure, I must change to minus SP. This continues until the test ends, whether I am running 15 total cycles as in this case, or running thousands of cycles. This makes the test complicated, especially for the operator, but it is something you could not do otherwise. You would run a test like this only if it's very important to get that kind of data. Finally, the test has ended. Look at the graph. Very interesting results. The resistance graph is a sawtooth. The resistance is higher when the sample is flat and lower when the sample is folded. We know that the top of the sawtooth is the flat measurement because the first and last values were done when the sample was flat. Let's look at the large graph. The resistance when folded, the bottom of the sawtooth, is about 24.8 ohms. The resistance when flat, the top of the sawtooth, is about 25.3 ohms. The tops of the sawtooth show the values when the sample is flat. The bottoms of the sawtooth show the values when the sample is folded. Sometimes this might be valuable information for you. So I simply show you this complicated test to give you an idea of what can be done with Flexdata.